with this problem, we are looking at converting this scenario into an algebraic expression. And we have two different costs associated with this manufacturing process. We have fixed costs and we have variable costs. Now, those words don't necessarily have to be like know exactly what they mean, except we can kind of think through what that means. The fixed cost of manufacturing basketballs in a factory are $1,400 per day. So it's going to cost us $1,400 just to open up the factory. The lights, the machinery, the employees, the whatever else. There's just going to be a cost of $1,400 just to turn the machines on, get the factory opened up. But so let me go ahead and write this down. $1,400, and that doesn't change. But the variable cost, you can see that's $5.25 per basketball. So notice the per basketball is telling us that this amount will change. That's probably just the materials cost. So if it costs $5.25 for the materials, then I'm going to have to spend $5.25, but that's entirely dependent on B right here, which is the number of basketballs. And because these are both costs that we have to spend, we're not talking about how much money that we're going to make from it or anything like that. So we have one cost, which is the fixed, and then another cost, which is the variable expenses. But we have to add all this up to get our total cost. And the total cost is going to be represented by K right there. So it's not too bad of a question, and most of you were on the right track. If you made a mistake, hopefully you can see maybe where maybe you read something wrong, and that's kind of where you went wrong with it. So hopefully you can take something away from this problem. So I always like to make sure that you guys are given kind of an explanation behind sorry, I got distracted for a second. So, oops, something got wrong there. Sorry about this. Sorry for that distraction. I always like to give some kind of an explanation as to why the area formula is what it is. We didn't really talk about the rectangle formula, but you guys are already kind of aware of that one from the past. The parallelogram formula, we kind of showed a little bit of reasons why that one is the way it is. The triangle formula, we derived that one a little bit. The circle area formula, remember that one is pi r squared. And that's a really weird formula, and there's no at least easily discernible reason why that's the formula. So there's a nice little video here, it's pretty short, just a couple minutes, that gives you an explanation. You don't have to know the reason why it's pi r squared, but I do like to give you guys that sort of background. So let me go ahead and share this.
Wow, look at this. 94% of people believe company culture is important to an organization's success.
Okay, then.
Pi r squared gives you the area of a circle. But where does pi r squared come from? First, we'll draw a circle and fill in its area. Next, we will divide it into large equal parts and arrange them in a rectangular formation. As you can see, it barely resembles a rectangle. So next, we will divide the circle into small equal pieces, and we will arrange them in the same manner. You can see that it appears more like a rectangle. So if we divide the circle into even more smaller pieces, you can see that every time the shape becomes more like a rectangle. So how small must we divide a circle before we can get a perfect rectangle? Well, we can keep on dividing the circle into small, smaller, or the smallest pieces you can make. But the answer is to divide the circle infinitely many times until we cannot distinguish the lines, and eventually the circle can now become a perfect rectangle. So the area of the circle is equal to the area of the rectangle, which is equal to base times height. The height of the rectangle, as you can see, is the same as the radius. So height is equal to radius. To find the base, we need to look at the circumference of the circle. And when we compare the base and the circumference, we can see that the base is equal to 1/2 the circumference. Remember that the circumference is equal to 2 pi r. When we combine it with 1/2, the 2's cancel out, and base is equal to pi r. So now base times height becomes pi r times r. Combine the r's together and we have pi r squared, which is equal to the area of the rectangle, which is equal to the area of the circle. So pi r squared can be used to calculate the area of any size circle that exists.
Okay, now maybe you followed along that entire time. Maybe you got lost a little bit, but that is one way of showing why pi r squared is the area of a circle. And again, as long as you know to use pi r squared, you don't have to know why that's the case. So I'm going to stop sharing this real quick, and I'm going to pull up another thing, which is your homework tonight. So your homework is just going to be some practice of all of the area formulas that we've learned. We had the area of a rectangle, of a parallelogram, which are basically the same formula, area of a triangle, and area of a circle. And so if we look at this homework, there's going to be some more parallelograms and rectangles. There's going to be some triangles, and there's going to be these right here. These are compound shapes, but it includes some circles. So it's going to get a little bit confusing. Notice all of these problems ask you to find the area. But, and this is listed in Canvas, there are some other things. If it's one of these that have a red circle around it, I want you to find the area and the perimeter. If it's one of these without the circle, then just answer the area. Don't worry about finding the perimeter of the shape. This red X right here, I crossed this one out. You don't need to do this one. This is actually a concept that we didn't learn in class. And I mean, feel free to give it a shot if you want to see if you can get it right. By all means, go for it. But certainly feel free to skip it. Okay, so as far as it goes, just like always, what I highly recommend is look through all these problems. And I'm not expecting you to necessarily be able to do all these perfectly and know exactly what to do. So if you get to a point where there's a problem you're completely stumped on, feel free to kind of mark that problem and, you know, get help from me. You can get help today, or you can come back to class tomorrow and say, this problem on the homework is one I did not understand. Can we go over it? And I'm more than happy to do that. So if there are problems from previous homeworks that you were looking at that you did not complete because you didn't understand how to do it, you know, you can feel free to ask those questions today. If you are good to go, if you understand what your homework is, you feel like you've got it all under control, then we're done. That's all I'm doing today is just getting you started. So you guys can have a wonderful day and stick around if you have questions. Otherwise, I will see you guys tomorrow.